Okay, so today what I'm going to do is I'm going to show you how to do some trig applications in complex numbers. Part A, find an expression for cos 5 theta in terms of cos theta. Sometimes I might say show cos 5 theta can be expressed as something so you know the answer that you're going for. In this case we don't, but I'll sort of know where to stop because I've got everything in cos theta. And then the second part is we're going to solve some sort of equation. The hence part means you'll probably use this here for said or otherwise you could do it another way, but they want us to do that way. So let's have a bit of a look at this. How can we get an expression with cos 5 theta in it? Well, if you consider the complex number cos theta plus I sine theta and raise it to the power of 5, by de Moivre's theorem we get cos 5 theta plus I sine 5 theta. Now this is nice because I've got both a cos 5 theta and a sine 5 theta. The sine 5 theta is nice because if we had to find an expression for sine 5 theta, we use exactly the same process. We just look at a slightly different part. The other thing I'm going to look at is I'm actually going to expand that using my binomial expansions. So we would write something like this, by binomial expansion, cos theta plus I sine theta to the power of 5 equals. Now I'm just going to pause it here and I'm going to write out my expansion just to save some time. So you'll notice I've used an abbreviation for cos and sine. So cos is just a C and sine is just an S. So there's an I there. You'll notice the cos powers go in descending order. So 5, 4, 3, 2, 1, none of them. And sine gets bigger. So there's none, there's 1, there's 2, there's 3, there's 4, there's 5. The coefficients in front, so it's an expansion to the power of 5. I just do a little Pascal's triangle. That's the coefficients for a quadratic, a cubic, power of 4. I didn't have enough space, but that's the power of 5. Just saves you writing 5C0, 5C1, 5C2, etc. What I'm going to do now is I'm going to change all these I squareds, I cubes, I to the power of 4s, etc. just in terms of I. So I'll just put it over here. I'll do it here. Should line up your equal signs. So that's cos to the power of 5 plus 5 cos to the power of 4 I sine. I squared is minus 1, so this becomes a minus 10 cos cubed sine squared. I cubed here is I squared times I, which is a minus I. So we get a minus 10 cos squared sine cubed I. I to the power of 4 is I squared times I squared, which is minus 1 times minus 1, which is a plus 1. So that's a plus 5 cos sine to the power of 4. And that's really an I to the power of 4 times I. So that becomes a plus sine to the power of 5 times I. So what that means is this expression here must be equal to that expression there. So therefore, cos to the power of 5 theta plus I sine 5 theta must equal all this line here. So cos to the power of 5 plus 5 cos 4. It doesn't matter if you put the I in front or behind. I've sort of changed it in different spots. Minus 10 cos cubed sine squared minus 10 cos squared sine cubed I. Plus 5 cos sine to the power of 4, and that was a plus sine to the power of 5i. So what we're going to do now is we're going to do this process of equating the real and imaginary parts. This part over here is real because there's no I attached to it. So it must be equal to that part, and that part because there's no I's. If we're equating the imaginary parts, we'd get an expression for sine 5 theta, which would equal that, and that. So you could write this, you can say equating real parts, cos 5 theta is equal to cos, I'm going to leave it as just C's at the moment because I've got a fair bit more work to do, minus 10 cos cubed sine squared plus 5 cos sine to the power of 4. Now, you might be tempted to stop there, but the thing is I need to write it all in terms of cos theta. So I need to change these signs to coses. Now you know the relationship between sine and cos using your Pythagorean triad. So I'm going to replace sine squared theta with 1 minus cos squared theta. I'm going to replace that with 1 minus cos squared theta all squared because that's really sine squared squared. So this is what we get. We get cos to the power of 5 minus 10 c cubed 1 minus cos squared. That's using your Pythagorean triads. Plus 5 cos 1 minus cos squared all squared. So this part here is really sine squared all squared. I can replace sine squared with that, and so I'm just squaring it. A little bit of expanding and tidying up, we get cos to the power of 5. Expanding this out, we get minus 10 cos cubed. Now that times that gives you a plus 10 cos to the power of 5. Got to expand this, and then multiply by 5 cos, so we get 1 minus 2 cos squared plus cos to the power of 4. Expanding this part here, we get plus 5 cos minus 10 cos cubed plus 5 cos to the power of 5. Okay, I think we're right now to start calling things coses rather than just c. So let's group together our cos to the power of 5. So we've got that part, and that part. So that gives us 16 cos to the power of 5 theta. So that's done, that's done, and that's done. We've got some, no, sorry, that was that one there. We've got these two parts here, so that's a minus 20 cos cubed theta. And we've also got a plus 5 cos theta. And that's your answer to the first part. So we've got an expression for cos 5 theta in terms of cos theta. There are some cos thetas raised to the power of 5 and cubed, etc., but they're still in terms of cos theta. I know I've got this right because if you look at these coefficients, see that 16, 20 and that 5, we're going to use those in this part here. I'll start a new page and I'll do that again. Okay, so the next part was to solve this equation. We just showed that cos 5 theta could be expressed as that. You'll notice the coefficients are the same, but the powers seem to be different, but that's okay. We'll deal with that in a little bit. So what we do is we do this. We recognise there's a relationship between these. So what we do is we let x equal cos theta. So what that means is, so therefore cos 5 theta equals 16 x to the power of 5 minus 20 x cubed plus 5x. Now if you take the factor of x out, it gives you 16x to the power of 4 minus 20x cubed plus 5. Now that's what we're trying to solve. So what we're going to do is we're actually going to solve this. So we're going to solve cos 5 theta equals 0. So solve this. Now if this is equal to 0, that means this is equal to 0 as well. So therefore either x equals 0 or 16x to the power of 4 minus 20x cubed plus 5 equals 0. Now it seems like we've gone in circles. I've just got the equation that I'm trying to solve by itself. What this means is if I solve this, the solutions I get from that are going to be this one and all of these. And if I can identify which one that is, the rest should be these ones. So let's go ahead and solve this. Now this is fairly easy to solve. So cos 5 theta equals 0. We take the cos over the other side, so we get inverse cos of 0. Now if you think of your cos graph, the first time it gets to 0 is 90 degrees, which is pi on 2. But it's not the only time it gets to 90. It gets to 90, if you think of your graph, blah, 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 goes up there, every 180 degrees. It's back there. So what we have to do is we have to add another k pi, where k is some integer. If we simplify this by putting that as a 2 on 2, and putting it all over a 2, we get a pi outside of 2k plus 1. And remember this is equal to 5 theta, which means theta is equal to pi 2k plus 1 on 10. Now if you take values of k, 0, 1, 2, 3 and 4, you get these values of theta. So when it's 0 you get pi on 10, when it's 1 you get 3 pi on 10, when it's 2 you get 5 pi on 10, when it's 3 you get 7 pi on 10, and when it's 4 you get 9 pi on 10. Remember these are values of theta. What we want is we want values of x that solve this. Now if you put these values here back up into this expression here, we get our x values. So I'm going to do that up here. So therefore x equals cos pi on 10, cos 3 pi on 10, cos 5 pi on 10, it doesn't go all the way, just there, cos 7 pi on 10, and cos 9 pi on 10. Now we've got 5 solutions for something that's only a quartic, so we've really got one more solution. Remember, one of these was x equals 0, so one of these is an x equals 0. There's cos 90 there. Now you know cos 90 equals 0. So you'd write something like, since cos 5 pi on 10 equals 0, the solutions, therefore the solutions to the equation, I'd write it out again, 16x to the power of 4 minus 20x squared plus 5 equals 0 are, and just list these ones, that one, that one, that one, and that one. There's your 4 answers to it.